Cosmic explorers, welcome to a journey beyond imagination. Today we embark on a voyage through the vastness of space, unveiling the wonders and mysteries of the universe. Brace yourselves for 10 mind-blowing facts that will challenge your understanding of reality and leave you in awe of the cosmos. Fact 1. Big Bang. The Big Bang theory is the primary explanation for the universe's origin. In simple terms, it proposes that the universe as we know it, emerged from a tiny incredibly hot and dense point. This point then expanded and stretched, initially at unimaginable speeds and later at a more measurable rate. It gradually transformed over 13.8 billion years, into the vast and ever-expanding cosmos we observe today. The Big Bang theory was proposed by Belgian physicist Georges Lemaitre in 1927. It is supported by a wealth of evidence from various fields of astrophysics and cosmology, and the most critical evidence is Hubble's law. In the 1920s, Edwin Hubble first observed that galaxies are moving away from us, and the farther away they are, the faster they are moving. This expansion of the universe supports the idea that it was once in a much denser state and has been expanding since the Big Bang. Fact 2. Incomprehensible scale. The observable universe spans a mind-boggling 93 billion light-years in diameter, containing billions of galaxies, each with billions of stars. The estimated number of stars in the observable universe is greater than all the grains of sand on Earth's beaches combined. The observable universe refers to the portion of space that is currently within our reach for observation with the aid of existing technology. You may visualize it as an expansive bubble, with our solar system positioned at its center. This breathtaking logarithmic view of the universe was brought together in one fantastic artistic finale by artist Pablo Carlos Buttici. As spectacular as this logarithmic view is, it only spans about 20 orders of magnitude, from the size of the Earth to the size of the present-day cosmic horizon, 93 billion light-years in diameter. The solar system gives way to the Milky Way, which gives way to nearby galaxies which then give way to the large-scale structure and the hot and dense plasma of the Big Bang at the outskirts. Each line of sight that we can observe contains all of these epochs, but the quest for the most distant observed object will not be complete until we've mapped out the entire universe. With each passing new year, another few tens of thousands of galaxies potentially become visible. However, this observable universe is different from the entire universe. While the observable universe is vast, the entire universe is believed to be potentially infinite and without spatial boundaries. As our telescopes and observational techniques have improved, we have been able to see farther and farther into the universe. Yet no matter how far we look, there is no evidence of any spatial boundaries or an edge to the universe. Fact 3. Dark matter and dark energy. Our universe is made up of 5% normal matter, 27% dark matter, and 68% dark energy. Normal matter refers to the everyday matter that we can see, touch, and interact with in our daily lives. It includes all the familiar substances that make up stars, planets, people, and everything around us. Dark matter and dark energy are two mysterious components of the universe. Unlike normal matter, dark matter and dark energy do not emit or interact with light, making them invisible. Dark matter pulls galaxies together, while dark energy pushes them apart. Galaxies spin incredibly quickly, much faster than what the gravity from visible stars, dust, and gas alone could explain. This puzzling discovery has led astronomers to propose a fascinating idea, that galaxies are enveloped by an unseen force, like an invisible glue, known as dark matter. This mysterious dark matter provides the extra gravitational pull, which is necessary to hold galaxies together despite their rapid rotation. However, even though it was proposed almost a century ago, the true nature of this dark matter continues to be a captivating mystery. After Hubble's remarkable observation of expansion of the universe in the 1920s, for a long time, scientists thought this expansion was slowing down due to gravity's pull from all the matter in the universe. However, in the 1990s, a team of astronomers made an astonishing finding: the expansion was actually speeding up. This discovery had a profound impact on cosmology, because it suggested that there's something else in the universe, which we cannot see, acting against gravity and pushing space apart. We call this mysterious force dark energy, but we don't fully understand it yet. This revelation tells us that our current theories of cosmology and particle physics may be incomplete or even incorrect. It's like a cosmic puzzle waiting to be solved, and it hints that there's new physics out there, just waiting for us to discover it. The quest to understand dark energy has opened up exciting possibilities for new discoveries and a deeper understanding of the universe. Detecting and studying dark matter and dark energy are significant challenges because they do not emit, absorb, or reflect light or any other form of electromagnetic radiation that we can directly observe with telescopes. However, scientists use a combination of indirect observational methods and theoretical models to study these mysterious components of the universe. For example, dark matter's main interaction is through gravity, which means it exerts gravitational effects on visible matter like stars and galaxies. Scientists observe the motion of galaxies, galaxy clusters, and even individual stars to infer the presence of dark matter based on the gravitational forces they experience. Fact 4. Flat universe. Based on current observational data and measurements, the prevailing scientific theory suggests that the universe is nearly flat on a large scale. According to Einstein's theory of general relativity, the distribution of matter and energy in the universe influences the curvature of space-time, determining the overall geometry of the universe. This gives the universe three possible shapes. It can be closed like a sphere, open like a saddle, or flat like a sheet of paper. On large scale, the universe has two forces, gravity and the force of expansion. Gravity pulls things together and is proportional to the mass, while the force of expansion pushes things apart. When the universe's gravity overcomes the force of expansion, the universe will curl into a ball and form a closed universe, like our Earth. In this case, the angles of a large triangle add up to more than 180 degrees, and parallel lines eventually converge, just like two friends walking parallel to each other on their way to the North Pole. A closed universe has positive curvature and would also be finite in space. On the other hand, if the universe's gravity is low and unable to stop the expansion, space will warp in the opposite direction. This would form an open universe with negative curvature resembling a saddle. The angles of a large triangle add up to less than 180 degrees, and parallel lines eventually diverge. When the universe's gravity and expansion balance just right, the universe is flat. The angles of a large triangle add up to 180 degrees, and parallel lines never meet. A flat universe implies that space extends infinitely and has no curvature on large scale. The universe is flat in 3 dimensions. There are basically 2 ways to measure the large-scale curvature of the universe. One is to measure the thing that causes space to curve in the first place, the density of energy and matter throughout the universe. Different shapes of the universe will result in different distributions of energy and matter throughout the universe. The second way to measure curvature is to measure the angles inside of a massive triangle in the universe. If the universe is flat, then the angles will add up to 180 degrees. But if the universe is curved, those angles will add up to more or less than 180 degrees depending on the type of curvature. To measure the shape of the universe, cosmologists created a portrait of the infant universe by detecting the first light after the Big Bang, cosmic microwave background radiation. Cosmic microwave background is a snapshot of the oldest light in our universe, from when the universe was just 380,000 years old. The colors of the all-sky map represent small temperature fluctuations that ultimately resulted in the galaxies we see today. The areas of higher energy are blue, while the areas of low energy are red. The variations in the all-sky map are very, very small, and the fossil light is uniform up to about 0.001%. This suggests that the energy and matter of the infant universe just balanced right, therefore the universe is flat. Cosmologists also studied the spatial relationship of the spots in the all-sky map. They measured massive triangles. The inner angles all add up to 180 degrees, which means that the universe is flat. It's important to note that the determination of the actual shape of the universe is a complex and ongoing area of research. Our understanding of the universe's geometry may evolve as we continue to study and explore the cosmos further. Just like we used to believe the Earth was flat. Fact 5. Big Freeze. Similar to the shape of the universe, there are 3 possible fates of the universe. Determined by the gravity and the force of expansion: Big Crunch, Big Rip, and Big Freeze. The Big Crunch scenario suggests that the expansion of the universe will eventually slow down and reverse under the influence of gravity. The universe would then contract, leading to a big crunch, where all matter and energy collapse back into an infinitely dense state, similar to the initial singularity of the Big Bang. In the Big Rip scenario, dark energy's influence becomes so powerful that it overcomes the forces holding galaxies, stars, planets, and even individual atoms together. This would lead to the tearing apart of all cosmic structures, resulting in a complete disintegration of the universe. In the Big Freeze scenario, the universe continues to expand at an accelerating rate due to the influence of dark energy. Galaxies move away from each other, and the universe becomes increasingly cold and empty. At the same time, stars within galaxies will exhaust their fuel and cease to shine. As they run out of energy, they will become dim and cold, and the universe will become increasingly dark and lifeless. Our current observations of the universe favor the Big Freeze scenario, and it is currently believed that the flat universe will expand infinitely in all directions. It's essential to emphasize that these are theoretical scenarios based on our current understanding of the universe. The actual fate of the universe will depend on several factors, including the amount and properties of dark energy, dark matter, and the overall geometry of space-time. This concludes part 1 of this duology. If you enjoyed this video, be sure to hit that like button and subscribe to our channel for more mind-blowing facts. Don't forget to share your thoughts and questions in the comments below. We love hearing from our incredible community of curious minds. See you in part 2.